Oh, good. Thank you so much.
Mhm.
All right. So welcome for those of you that are here, and I'm know that we're definitely gonna have people joining online because I've already gotten emails about that. So thank you for those of you that are joining online. I am Sarah Abood. We have Rashna Nath here for our DRIPBL team, and we have our wonderful speaker who is part of our speaker series, Derek Sollberger. And he is a lecturer with the CSML, which is the Center for Statistics and Machine Learning at Princeton University, where he teaches data science, intelligence models, excuse me, and Bayesian analysis. And those are the things of the future. And he has led several R programming workshops with ESL, which is Engineering Service Learning, and is a POSIT certified Tidyverse instructor, which I know I had to look up, but it's very impressive. And previously, he has taught at the University of California, Merced, where he brings his experience to Princeton University as a data scientist, as data analysis consultant for research projects in pedagogy. And we are so lucky to have Derek here. He is going to be talking to us about pollinating your future, data science skills with bee data, and some college insights. So thank you for being here, Derek.
Thank you, Sarah. Thank you, Rachna.
Yeah.
I was just thinking now about my career over the years. I actually started as a high school tutor, worked my way up, and yeah, as mentioned, I now work at an Ivy League private university, and it's been great. My usual audiences are college students, and when I'm doing workshops, computer programmers in the data science community. And to be honest, I wasn't quite sure what I wanted to bring to this audience. So what I thought I'd do, and I discussed this with your DRIPBL host, is that maybe I'll spend about half an hour doing one of our workshops, giving you a sense of what it's like a day in the life of a data scientist, what we do, and then we'll spend a few minutes after that where I hope to impart some advice on those of you who are applying for colleges who might be considering a data science major and so forth. So with that said, I need to figure out my Zoom here. And do we see a window with two tabs in it? Okay. I myself am slightly not conventional. I don't like to do slides, so I tend to put my materials on blog posts. It's just how my brain works out. And what I like is that for my audience, if I'm going too fast or too slow, you could follow along on the blog post that I just linked in the chat, and you could see the materials if it's easier to view that way. So overall, from the data science community, especially when you're working in business, say if you're a consultant at a bank or a pharmaceutical company, the big technology is what's called dashboards. The idea is to be able to share information about your data in a way that your user could flip through it, could click through it like any other web page, and to be able to express a lot of information quickly. And what I envision in this particular technology is informal settings. If you're meeting with your teammates, if you're meeting with your classmates about once a week, these are not necessarily full-fledged apps that you would deliver to hundreds of customers. This is for inter-business communication with your teammates. So the technology are called Quarto dashboards. Quarto is kind of the coding framework. And apologies in advance, I do not mean to insult anybody's intelligence. It's just I do not know where your computer programming skills are. So I'll just express some ideas along the way. And in addition to showing you what dashboards are, I'll show you a little bit of the programming technology behind things, and that's called Shiny. Thanks again to Sarah for giving me a wonderful introduction. Just to mention some of my interests, I did my education at UC Berkeley and Long Beach State, worked for a decade at UC Merced. My research interests tend to be in pedagogy, in how to teach, geospatial analyses, and sports statistics. And outside of that, you could usually find me at a sushi restaurant. So what we mean by dashboards are clickable uh, devices like this that, again, allows people to look at a lot of information about their company pretty quickly. And say, for example, in this dashboard about stocks, we're looking at a particular stock for the Boeing Airplane Company. And for purposes of our demonstration, I want to look at the top row where it says current price. We're calling those three value boxes. And then in the row below that, we see a graph and we see a table. What we're going to focus on at first is making arrangements like that. But moreover, you see that in a dashboard, we are presenting, in this case, a graph, a table, and also highlighting three important numbers right at the top of the screen. We are concerned about being able to present all that information and also guiding the viewer into what may be important at the time. In the R programming language, we load up some packages to be able to use that code, and I've brought in some data that I'll explain shortly. Back at UC Merced, a lot of my students were biology majors, and that was a lot of my job to teach statistics to biology majors. Long story short, statistics is how you measure the results of your scientific experiments. And at some point, I was deeply concerned about some news that I was reading at the time, and as you can see, it's about bee populations. And what I thought, well, let's go ahead and set the scene first. Here on the left, we see an article from Time magazine that says North American bee species, many of them were headed towards extinction. And on the right is an article, the article on the left from 2017, the article from the right from 2019. The article on the right is from ABC News corroborating that, saying that there was a nearly 40% decline in the honeybee population and worries about it being unsustainable. Now, we as scientists, as statisticians, etc., are able to double check information and see if there's some veracity, if there's some truth to these stories. So I thought that's what we would do here. My data source is coming from the United States Department of Agriculture, National Agricultural Statistical Service, USDA NAS. And it takes you to a web page like this. And in particular, you'll notice in the top right how I'm counting the bees. It's not feasible to count honeybees individually. So I'm using the colonies, the number of bee colonies as a proxy. As a scientist, I'm also keeping this information here on this blog post for what we call replicability. That is, if someone else wanted to do these calculations, they could see exactly which steps I've taken and could run these calculations on their own computer to verify them. So let's start off with some bar charts. We have the number of bee colonies in millions on the vertical, on the y-axis, and the year at the moment when I got the data, the most recent years in the data frame or in the time frame. And we do observe that, say, from 2016 to 2017, there was a sharp drop off in the number of bee colonies, and that is cause for concern. What I tend to do with my students is, if they're ever curious about how I made the code, I always put the code right next to it so that way they could refer to it later. Now, in the data set itself, we could also look at how the populations trended, decreasing or increasing for each state. Here, I'm looking at New Jersey just because that's where I am now. And we actually do not see cause for alarm. In fact, the number of bee colonies were increasing in that sense. And we could do this for each state. Now, what I'm concerned about in this exposition, in this storytelling, is there are about 50 states to show, and you probably do not want to show 50 graphs to someone. That would be what we call information overload. And a bit on the verbiage there, the reason why I say about 50 states is because when you talk about geographical regions, you may also be including places like Washington, D.C. and Puerto Rico. So that's why I'm approximating that particular number. But anyways, we have a situation where the audience, the viewer, whether it's someone that you're working with, or maybe even later a client might want information about these individual states or regions. But again, you do not want to show all 50 of them at once. So that's where the motivations for these dashboards come in. Could you leave a situation where you could bring up all these graphs one at a time that's very user friendly? And as always, if you have any questions, please go ahead and post them in the chat and I'll try to get to them. Another type of data is what's called geospatial data. Here I have a quick map of the contiguous 48 United States, and obviously highlighted New Jersey. Now, for geography purposes, your audience will probably know what the United States are and where they are. Like even when I talk to my colleagues in places like Germany and Italy, they know where New Jersey is. However, maybe in the future, if you're working at, say, a commerce company and you have factories and stores and you want to point out individual locations, that information might be not as common, and it might be useful to likewise have geography, to have maps available. So what we're going to do is, in addition to showing 50 bar graphs, we're also going to point out which state we're talking about on the map. So as I mentioned before, when we have layouts like this, we're looking at first at what we call cards. On the first row with current price, I'm saying that's a row with 3 cards. Next row down with the graph and table, I'm saying that has 2 cards on it. All right, so what I'm going to try to do is to actually do this in what we call live coding, a live demonstration. As a teacher, this is always fraught with anxiety because things could go wrong pretty quickly, and you could just see me mess up in front of you. So that's the risk we take. This is a workshop that I developed last January for coworkers, and quite frankly, I'm hoping I still remember what I'm doing. Let me see if I could increase the font size a bit. So what I'm trying to do is create what's called a quarto document, which is like a website. As always, put your name on your work. And in order to create a dashboard, we change the format to dashboard, and we're done. Yay. Of course, we probably want something to actually appear there. So we probably should add what we call content. You know, people are content creators. So what we could do then is to start to create an arrangement. Over the years, you may have heard that computer programming is difficult, and it can be. But over the years, there have been technologies where software engineers have actually made it easier for people to learn these skills. And what I'm doing right now is a type of computer programming called Markdown language. That is, I don't have to code a web page directly, but I could use these shortcuts. So you can see that when I use one hashtag, it creates a row. And when I use two hashtags, it creates a column. Now, in order for us to see what's going on, I'm just going to put in some placeholder text here. And remember, I'm trying to talk about a notion of arrangement, just trying to get a sense of where to put objects. So right now, what I'm doing is I um, created a dashboard with a couple of rows like we saw in our example from the documentation page. And we could also have these tabs on the top here to arrange things as well. So what I accidentally did was I used too few hashtags for rows and columns. So let me go ahead and fix that really quickly. This is the joy of live coding. And now this is our arrangement. First row has a couple of columns in it, and the second row has 3 columns in it. And the idea from here is then to put information such as tables and graphs into each one of those cards. All right, so when we give a workshop like this, especially with a variety of people with a variety of coding experience, things could go wrong for any of us. We might have typos. We might accidentally lose track of each other. So what is useful is to, for a presenter like me, is to have templates available. For example, maybe every 20 minutes in, everyone in the workshop audience would go to a certain template so that way we could all come back and start at the same location, just in case there were bugs or typos along the way. So I forgot to install some code packages before this presentation, so I'm just waiting a minute for some of the technology in the background to come into play. But while we're waiting, again, if anybody in the audience has questions, feel free to ask them in the chat. And for the current question, what I'm doing is pressing the render button. It transfers the information from the QMD code to make the dashboard, to make the website.
And then could you just remind us what, so I get that this is your, like what, so what language are you using? And so I don't know how to word the question. So is this like an R GUI that's like our R Studio type thing, or like what is this that you're using here, this environment?
Yes, thank you. So overall, I use a programming language called R. It's literally the letter R. And those of us who work in data science, statistics, and probability like it. And It also is very popular in the public government sector and in biomedical industries. From there, inside this software, our studio, I am using a framework called Quarto that helps bridge the gap between R and making web pages and other products such as applications. And what I'm expressing is that the coding has been made relatively streamlined and simple. So now, at this case, I have also brought in information about from the maps, the United States, and also information about the bees themselves. So as we move along here in the presentation, you can see I've changed up the arrangement. So we have two columns. The first column has two rows in it, where I'm eventually going to put a bar chart in the top left. The second column has three rows in it, where for now I have an orange call out, sorry, an orange value box here, which will eventually highlight information for us.
Mm.
Just double checking my notes, see where we are. So I want to put the New Jersey map in a place where I want that to appear, and I want to give that a title. So that way it will appear when we render the document. Also, continuing to plan ahead, I'm going to have the year show up here. And remember, we are trying to get a sense of the number of bees, the number of bee colonies. So I'll eventually have that shown here. In the code, I know what it's doing, but I'm rendering the document right now so that way we could see a bit more.
Mm.
And you can see this is a relatively quick process, and I'm starting to get the arrangement where I want it. Some things are loading in kind of a funny way at the moment, but we are making progress. I'm about to go into the really complicated stuff, so once again, if there are any questions at the moment, please let us know. For an aside, someone messaged me that they are the mother of one of my current students, so that's actually pretty welcome. Admittedly, from DRIPBL, I posted the flyer around my office building just to say, "Hey, I got a speaking engagement." So yeah, I'm glad
Oh,
to meet people
that's
here.
so nice.
All right, so for this next part, I'm going to go back to my quote unquote slideshow, my blog post, which I'll link again in the chat if you want to follow along that way. In addition to these dashboards, where these technologies really take off is to make them interactive. Remember, one of our goals is to allow the user to actually pick which state they want information on, whether it's California, New Jersey, etc. And the interactive content is made possible through a framework called Shiny. This is essentially streamlining the process so that a programmer does not have to do every bit of the JavaScript code, but is able to make interactive elements in a relatively short amount of time. Now, when you dive into Shiny programming, you need to know some of the architecture. And on the screen, you get a sense of what that is. you have these two separate scripts, one talking about the user interface and one talking about the R server. The user interface is what your audience member, what your user sees on the website, and the R server in the background is what handles the calculations in the background. So when we program these items on the left in the user interface, we have functions such as select input, which asks the user which state and which year they want to focus on. And then eventually we'll have functions like plot output, which will make things like the map and the bar graph. On the right, these correspond to variables. And to use them, to go a little bit more technical in the language, these are in object-oriented programming settings. We have what are called the input object and the output object. So we have to go input $variable or output $variable to keep track of everything. And you'll notice it's the color coding where the variable names are coordinated with each other. So for example, if select input takes in some information, it's going to be stored in color_var. And in order to access that in the background in the server there in the top right, we use input $color_var. I'll show you more of this in the actual code. Let me just double check where we are. When you're working with technologies like this, you want to read the documentation, get a sense of what the software engineers have made available to you. And in particular, you'd have to tell the code that we are making an interactive dashboard using the Shiny framework. And you have to tell the code where the user interface is and where the server is. So let me see where I'm at now. So again, telling the software that we are going to make this interactive. And we could make the slider inputs to allow the user to choose a state and a year, and eventually be able to see their bar plot and some other information as well. So on the left side, we have the select input, which allows us to choose the state. Admittedly, nothing else is happening at the moment. It allows us to choose the state and allows the user to choose the year. So you can see otherwise, what I'm hoping to do is to have that bar graph in the middle change and also have the key information show up there in the value boxes on the right. Just double check my notes to see where we are. What I would do in a professional workshop is then ask the audience members, the students, to fill in some information. And if you're following along with the blog post, you could see what the instructions were. But for our sake and to continue talking about things at a high level. And once again, I'm hoping that I'm giving you a sense of what it's like to be a data scientist, to make projects for clients and to express information. So now what I have is another version of the Shiny dashboard that's a little more ahead into progress, where I put some of the tabs here at the top, scene, states, and data. So that way I could tell my client the story, just like I told you. And then I have information about the data to talk about veracity and replicability, to say that the data is a real source. And that way we could have truth behind the storytelling and the journalism. In the middle is my actual dashboard, which is coming together. It's still not quite interactive yet. I need to actually connect the code so that way for the interactive part, if I change the state, for example, both the bar graph in the middle and the map on the bottom right should change. You could kind of see this in the top right that I have it so that the state name changes. So at least at that point in the development process, I knew things were working. So then finally, the nice thing about giving workshops like this is that I'm not a university teacher. I could just give out the answers. So I usually just put that in a document called Z end. So especially if I mess up things along the way, I could assure the people that have volunteered their time to attend a workshop like this, or quite frankly, paid for a workshop like this, that they would still get the information. So here is the final product for a dashboard that in a workshop setting only took us about 2 hours to make. We have the scene once again, the data, and the the main course in the middle. So we will focus, say, on California, and hopefully now the graph and the map will change. What I furthermore did was when choosing the year, it will change the highlight on the bar graph, and it will change hopefully the information there on the top right as well. So maybe going to Arizona, we see that there was some slight population fluctuation, but in the most recent year data, there were actually many more bee colonies. We could also talk about this from a maybe a sociological perspective that if we're counting bee colonies, we're actually counting the agricultural bees that are domesticated and are kept by farmers. And coming out of the pandemic, there are actually more apiaries, more people who took up backyard beekeeping and so forth. And we're actually seeing an increase in bee populations in this one metric, as according to the United States Department of Agriculture. I'm being very careful about how I'm saying my story because at the beginning, we saw articles that said many bee species are facing extinction. And that may still be true because I'm only talking about certain bee species in this particular data.
Derek, I had a question. So for people who are going through and looking at something like this and creating a dashboard in Quattro, when they create something like this, it seems very internal, right? It's in their dashboard that they're making. How would they then, if they're making this for themselves or for their own project or for a client, how do they then get this out there, right? How do they get this to the public? What's that
You are
process like?
you are correct. That process is called publishing. And unlike having to publish a book or magazine article, anybody could publish. Most people use a repository called GitHub, and they will go from their GitHub code and create a web page on top of that called GitHub Pages. Um, for other purposes, for example, this web page I'm showing you right now, my blog posts are hosted on GitHub, but I use a service called Netlify to transfer it onto a web page to make it easier for me to publish my thoughts whenever I have them. Now, while we're here, we should also talk about data security, data integrity. There are a lot of companies out there for whom data is a confidential matter and they do not want to publish it outside of their company. And thus, this is a motivation to have, like you said, these dashboards be internal documents that are only shared amongst coworkers. So there are concerns about that as well. And if you're in a situation where you are working with a client whose data is confidential, but you want the outputs, such as the graphs, to be public, yes, you would handle that along the way, and you would have to worry about the security measures in between those steps there. So then what I do in the workshop, just to finish off some thoughts, is I thank the audience. For this particular audience, we still have maybe about 10 more minutes of material to discuss. I would thank the computer programming audience for participating in the workshop. It's about 2 or 3 hours. And I would fully admit it's not everything. This was an overview, a tutorial, and I would thank the data scientists who made this possible. The data science community is very good about making tutorials and blog posts to share information, to onboard people who want to learn this stuff right after them. So this technology that I showed you is about 2 or 3 years old, and I was able to put this together thanks to resources like the one I'm sharing on the screen right now. And we could talk a little bit more about the B narrative if you want to. We could talk a little bit more about the R coding if you want to. But moreover, I was excited to talk with this DRIPBL audience and to bring my perspective as a college faculty member to talk about preparing for college. And that's what I'll do next. But for now, I once again welcome more questions from the audience if you want to talk more about the R coding or the B story.
So, Derek, I have a question. So these students, they struggle a lot on the data analysis component of their projects. So even if they have collected a lot of data, there is a big emphasis on how do you statistically analyze the data. And it doesn't matter whether you are a sixth grader or a 12th grader. The more you can show different kinds of statistical analysis, the more the relevant it is, because now you're talking about significance and non-significance, and you do so. And also there are many softwares that are available online as well, but it costs a lot of money. Do you have any like a free resource for the kids where they can go in, put in their data and ask it to be analyzed in a certain way where some of them don't even know how to analyze the data? That's a different concept altogether. But for students who have been, say, in the 9th, 10th, 11th, 12th grade, where they have some concepts of that, do you have any free resource that these kids can use where they're not paying a monthly subscription of $60 to just get a data set analyzed for 2 months? And it's a yearly subscription.
Okay, so to the first question about how we get a sense of how to display data, how to analyze data. The analog is just how do we learn anything. You ever, when you just giving a long-winded answer, you ever go back and teach someone English grammar or maybe grammar in a foreign language such as Spanish? You yourself picked it up because you read a lot of books and you just got a sense of how the language flows. The same thing happens in data analyses. You read a lot of scientific literature, a lot of scientific communication, blog posts are fine, maybe social media posts as well, and you get a sense of how people are presenting their data. Statistics is frustrating because it does veer away from mathematics in that they're not necessarily right or wrong answers, but there are norms, there are customary things to do. Like, for example, in my B data, I happened to feel that bar graphs were the best because I knew how the years worked out. Now, for your second question, admittedly, because I teach students who not only want to use ChatGPT, I'm trying to teach students how to make the next ChatGPT.
Mhm.
And our missions are a little bit different. To your question about software that will make the data for you, I don't remember them off the top of my head, but there are definitely some.
Okay.
ChatGPT could do this on some level as well. But as I hinted at the beginning, a lot of my audience are biology students, biology teachers who do not necessarily need to do full-fledged programming for their work.
Mhm.
And yes, I agree with you. There are software out there that could take a data set and allow you to play with that. Some of the students here probably know this better than me. There are also settings that teach computer programming in a more modularized way, as if you were assembling Lego pieces. And I think that was called Scratch or something thereof.
Yeah, 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 yeah. No, a lot of kids use Data Classroom.
Hmm.
And Data Classroom is something that needs subscription. And we were asked to use it, but we got a subscription from the school because the district took it because it was free for the kids. But then it's not the same with other kids. And statistical analysis is at least 20% of the grades of any student's science competitions or science projects. They have to show that expertise. So yeah, that's one of the things. And I feel that the free resources that you're showing is phenomenal because um, a lot of kids don't know. I didn't know most of the things as well. So thank you. Thank you so much. Anything
Yes.
else? Any other questions? Sorry,
Yeah,
Derek.
the overall point on that is I'm showing you our programming language. The most popular language in this realm is obviously Python.
Yeah.
There is a bit of a learning curve, and I'll mention that in a few minutes.
Yeah. Everybody put your questions in the chat, please, if you have any questions at all.
And that could
Sarah
also,
brings up a good point. If you put your data into ChatGPT, it shares your data with ChatGPT. We briefly discussed the notion that you, your company, your organization, the data is probably confidential.
Yeah, I think that is where I don't know how this works. I've never tried it, but there is a potential private setting that you can put your ChatGPT in whenever you're using ChatGPT, and I've not tried it, so disclaimer. But I was told that you can use your private setting where the ChatGPT is not sharing the data and it's going out to the world, but it stays with you, but it'll still analyze and process it for you. And I
it's
don't know if
a
that's right or wrong.
it's a different so different AI, generative AI, and these different types of services, they have different subscription
Subscriptions, yeah,
costs.
yeah,
And so
for sure.
pretty much the highest one allows you to do that. But most people, I feel like, use the free one.
Yeah.
And they supply to students typically the free version,
Mhm.
and they don't have those
That's not, yeah,
options.
yeah,
So
yeah. And
just something to worry about, especially
yeah,
because we know that a lot of students are going through and working on their own collecting their own novel data for
mhm,
projects. And
exactly.
if you're presenting that at a competition, that's not necessarily something you want shared.
Not on ChatGPT for sure, because that data set will now be used to feed off of somebody else's response. And they'll say,
Mhm.
hey, this is an amazing data, use this. But again, do not know where it's coming from, particularly if you are
Yeah.
looking at references. A lot of those references are also bogus references. So always double check. If you say, hey,
Right.
cite my source, a lot of those are
Yeah.
bogus citations.
Yeah.
Yeah.
But but Derek's pretty much getting at, if you are putting in, if you want a general value, if you will put in some means with no real scaffolding, right?
Yeah.
Or description, you say 23 plus 24 plus 37, give me a mean, it can do that very
Yeah.
easily. So these are different things that it can handle, but that's also something that really easily can happen in R, and learning those skills in R and learning that language to then hopefully guide you to learn Python a little bit later. and Derek, please correct me if I'm wrong, because I'm not an official data scientist, obviously, as you know, but learning that R language first is definitely a skill for later development and can help you get some better graphs later on, help you with more of these codings and things like what you just saw him do. And so it's kind of going to help you more in academically and potentially career wise. So learning that those little skills now for little things, even for data analysis, isn't too hard. And you can ask things like ChatGPT for help on code. If you're having trouble understanding and going through, say, the guidance through GitHub or all of these other websites, if it's too hard for you to understand. So learning how to use the coding tools in ChatGPT is a pretty handy tool for those things. Derek, is that on base or completely off base?
I completely agree with what Sarah said. It's the general advice that programmers share with each other as well. Use the AI chatbots such as ChatGPT to help you with individual tools, but not necessarily asking it to do your whole entire project, your whole entire analysis. For example, I happen to program in multiple languages, but just even in spoken languages, like say, if I need to know how to say dog in Polish, I could ask a GPT to do that for me. But I don't necessarily want the GPT to transcribe my whole essay in Polish or something thereof. There's also the issue of replicability. That is to say, if you're doing a calculation, you want the same answer every single time. GPTs might actually give you different answers. If I ran these calculations right now, it might say that the bee population is going up. If I ran the calculations maybe 10 minutes later, it might say that the bee populations are going down, and that would be quite confounding to us. If you were the programmer that were carefully doing every single step along the way, you know that the calculations are solid.
Yeah, that's a really good point. All right, so what questions do people have? And this could be super general. It could be, really specific to Derek's experience, whatever it may be. What questions do we have about college or Princeton or data science in college?
And also, you all been probably working together for a while, but I'm the new person here. If the students in the audience, if you're comfortable sharing, could just tell us which grade you're in, that'd be great.
Yeah, please put it in the chat. Put it in the chat, please. And Derek, I have a question for you. So when I was a young kid, I don't know when, I chose biology because I dreaded math. And I thought that I'm not going to need math. I'm going to just stick with biology. I'm going to become a doctor. And then reality knocked me in the face when I came to grad school. And the very first time I had to do statistics and I had to do R. In R, I had zero experience of programming. I did not know anything. So do you recommend these students who are also biologists, who wants to do biomedical engineering, a lot of the hype on biomedical engineering, do you want them to also tinker a little bit on some programming languages sooner than later so that they don't get a slap in my face like when I did, thinking that we are not going to need programming at all in biology?
So a big source of friction that we have, especially amongst biology students, is the notion that a lot of people understandably want to go to med school and become doctors. And the competition is so fierce that everyone is understandably greatly concerned about their grades. And if you're trying to get an A in everything, it creates a reverse incentive that the students might actually be taking the easiest classes along the way. So what I'm going to show on this screen right now is what you're asking about. My advice is before you get to college, go ahead and just take the time to learn the programming language now. During winter break, during summer break, learn a programming language, and I would recommend either R or Python. There are a bunch of free resources online. You could learn quite a bit in a couple months, try out a few lessons to see if you'd like it. And if you stick with it for a few months, you could even earn a certificate that you could put on your college applications. Now, I will fully admit I'm biased that most of the time I teach in R because, in my opinion, it lines up with the ideas of data science more closely, such as focusing on certain columns of information. And you can see in my quick table there, in R, it tends to be better for data science, dashboards, interactivity, visualization, and debugging. We went over most of those today. Whereas Python is a language that is more ubiquitous, used by many places in industry, is better for machine learning, software development, object-oriented programming, big data, and just tends to be a faster language in general. But again, my advice to the audience members here is, yeah, to spend a couple months next summer, learn a language. And if it turns out you don't like it, you don't like it, fine. But at least you took the time to learn it. And if nothing else, you will also get a sense of, if you encounter applications, if you encounter websites like this, you get a sense of how things were made in the background and why things went right, why things went wrong.
Thank you, Derek. Sarah, there are a couple of questions in the chat. So
Yeah, perfect. So, Derek, what are some college programs best suitable for students keen on stats and biology?
Could you elaborate on that?
Hari, could you elaborate on that?
maybe we can go to the next question before he types in. Yeah, or maybe you can.
Yeah,
Hari, you can.
sorry, I was trying to unmute and
Oh,
yeah.
Harita.
Yeah, so I have a sophomore in high school who is keen in biological sciences, plant sciences, and has a bent of mind of analyzing data. He's doing AP statistics. These are his interests, but unfortunately, being a software engineer myself, I can't seem to guide him on what pathways might be suitable in college for his pursuit beyond high school. Wondering if you can suggest any programs that we can look into for him.
At the college level, and this mixes in with another question that was asked in chat, even when I was in college, the job industry was changing so rapidly.
Right.
I myself could not major in data science because it did not exist at the time, for example.
Right.
And my advice to students, and I'm biased because I'm at a very good college where students are successful pretty much no matter what, is just to study what you want. And as long as you demonstrate that you are good at what you do, you will eventually be successful. And there was a question in chat about how will AI affect the data science industry. Oh yes, it definitely already has. And it is pretty rough out there. All you could do really is to pick up a bunch of skills along the way, but be flexible. Like I myself, I did not think that I would be at a job where I give oral presentations multiple days a week, but here I am. And that's actually how I make my living. And I just happen to do some computer programming on the side. This leads us into my last slide of the day, is at least on the preparation side of things, what I would advise for people who want to pick up some of these tech skills. First and foremost, AP statistics is becoming more and more important. And again, this might be a necessary evil. You, your student, might not like AP statistics. You don't have to like it, but you'll get a sense of how science is done and how science is measured. AP calculus, if you can, take it. It's actually not as important because you'll be most likely taking calculus again in college anyways. Now, to the question about resources, maybe before college, my advice is to seek out summer camps. For families that have high resources and that can afford it, there are excellent summer camps out there. For example, in data science, there are, say, 3-week boot camps that teaches you almost all the data science skills that you would ever need, machine learning, maybe some artificial intelligence as well. Now, I should warn you, some of these could get pretty pricey. These are on the order of about $5,000 per student. At least at my university, we were able to subsidize and give scholarships to the students. And it was great for the students. 3 weeks at Princeton University, all expenses paid, including lodging, airplane. We taught the students in 3 weeks, and they are arguably as competitive as college students at that point. But there are other summer camps out there. I don't necessarily want to advertise them because there might be some good and some bad. But understandably, not every family has a spare $5,000 per student for a summer camp. So I do want to offer some advice for families that have maybe lower resources. If you haven't heard about it already, I would highly advise you to look into QuestBridge. So what QuestBridge does, off the top of my head, and I imagine Sarah and Rachna could tell you more, is that it'll prepare your college student by helping you write college essays, helping you with study skills, SAT prep, etc. And I believe the deal is when you work with QuestBridge, you make a ranking of the schools you want to go to. But if the schools accept you, you have to go to the school that was highest on your list. So there's a bit of a trade-off there. Now, at Princeton University, which is by some metrics the #1 university in the United States, we accept only about 7 or 8% of applicants. It's a highly competitive process. What I advise students on that end is just go ahead and apply. It's no shame being, in the worst case scenario, part of the 92% that got rejected. But for the students that are here, they love it here. Obviously, I'm biased, and it was worth their time. When Princeton seeks out a variety of students, and here's the insider information. When Princeton seeks out a variety of students, they go to QuestBridge first. They look for QuestBridge students, and they try to accept several of them because they know QuestBridge students are ready for college.
Well,
That's amazing information.
yeah.
Thank you,
And
Derek.
it really is an amazing program.
Yeah. Yeah, and I mean, I'll talk later. Go ahead, Sarah. I think there are a couple of other questions, and we're almost at the hour.
Yeah. Well, I think actually that's all the questions that I see, at least.
Oh,
Because Derek went through and was reading them and answering them as
I
he was
see.
going.
Okay.
And you little bugger, you anticipated them and you already had the answers in your dashboard and your blog. So I just want to kind of just thank Derek so much because I've known Derek as a teacher for a really long time. I know that he is a wonderful teacher. He really emphasizes the student experience, and I know that he also is a huge advocate for the community wherever he is, and he's a huge advocate for obviously his students, and his students always speak so highly of him. So I was just really grateful to get a little piece of that today. So I thank you personally, but also for all of us here. And I know that today was maybe for people who don't have that coding experience, maybe it was a little tough, but this is just a call to say, hey, let's learn those languages, right? Like learn that R, learn that Python, so we can get a little more comfortable with what Derek was going over. Now, if you have some other programs that you're interested in, maybe we can work with Derek and create some type of workshop in the summer or something that you can learn some of these languages a little bit more. So if you're really keen on and enjoyed this program, throw some love in the chat and say, yeah, DRIPBL, try to get Derek to work with us. And also, in general, just thank you so much for being here. I will say that we have another session that's coming up on November. Oh, I don't want to misquote anything. Let me double check. Then the day. We have one coming up on November 15th. Again, that's a Saturday, and it's going to be focusing on biochemistry and academia with Dean Jackie Trishman at CSU San Marcos. And she is a wonderful person, and it's going to be an interesting insight to get that from a dean of CSTEM. And she's going to provide a different insight than we got from a data scientist today. I think that if you are able to come from today and next month, you're going to see some common threads. People in academia are super kind and lovely and wonderful people, because that sure is what Derek is. So thank you so much for being here. Really appreciate it.
Thanks
Thank you.
all.
Thank you. Thank you,
Right,
Derek.
like this.
Appreciate it. Yep.
All right.
Bye.
And yeah, bye. Thank you so much. And if there's any other questions or things like that, feel free to let us know. We will be putting up this recording onto our YouTube. And then if it's possible, Derek, we would love to put the course link that you had. If not, we don't have to include that. But let us know what you want us to include on that page, so people can, on the YouTube description page. I don't know. I'm not that tech savvy, obviously. Derek, you're the tech savvy person here. So just let us know what you want included, and we'll be happy to do that.
Yeah, and I'm also putting the link of our group chat in the thing. If you guys want to connect with us on that as well, you can join that group chat for sure, and then connect with us if you're not already there.
Yeah, perfect. All right.
Thank you, Derek,
Yeah.
so much. So me and Sarah will reach out to you for potential ideas that we have to connect and give these kids a lot more opportunities that they have. That is not as expensive as what are things out in the market with low quality.
Yeah.
But for sure, we'll reach out. Thank you again for your time.
All right.
Thanks all.
Thank you
Have a
so
good day.
much.
Bye.
Bye. Bye, Christina. Bye, Christine. Sorry. Bye, Rashna.